That's just the way it is. But I'm going to try to make it as, like, basic and straightforward as I can. So, let's start off. We all played Uno, right?
Yeah.
We all understand, like, the rules of Uno? Okay. So, we first have a 5. You're given a 5. And we want to use these cards to get to 9. So, what would you put down first? Which 3? Why would you do that? What would be your reason to put down the 3 blue? Blue. 3, that's blue.
Then you can put the red on.
Because it's the same color, right?
Yeah.
Okay, then what would you do?
The red 3.
Red 3 because it's the same number. Then what would you do?
4.
Why?
For the same color.
Okay, then what? Why? And then finally you'd end up at 9 because they're the same color. Right. So that's all from physics, guys. You're just telling a story. You're just getting from one place to the other and saying what you do as you get there, right? It's easy when it's things we know how to do. Let's practice another one. Start with a yellow 0, and you want to get to a red 6 using those cards. So think about a plan, maybe tell your neighbor how you would do it, and then we'll go from there. Okay, so think of a plan. What would you do? Blue what? Okay. Blue 9. Green 9. All right.
What?
Dylan, this is really easy.
Oh, you have no clue what we're doing.
Let's try. We'll do one more. We'll do this one. You want to use all the cards.
All the cards?
Use all of them.
All the twos. I'm gonna flip this. Down to the yellow. This one is a little bit different.
I would go green 2, yellow 2, blue 2, blue 8. I mean, and green 8. Is that right? Wait, is that what you do for everything?
So far.
You just have to find like how one can change the other. It's like remember.
So what would one of you do after the red 2?
Yellow.
Yellow.
Yeah.
Green. Blue. Okay. What if you wanted the shortest route possible?
Blue 2.
Yeah, you don't even have to use the green and yellow. So there's more than one way to write a proof. Okay? So just know that if you have something down and your friend has something different, you might both be right. You might both be wrong. You don't really know, right? Now we're going to go over that yellow sheet. Those are your reasons. Honestly, just study this, and this is what you're going to write down for all your reasons when you write your proof. And we've already talked about adding, subtracting, multiplying, dividing. All those hold true when you have a segment as well. And then we're going to go over some new ones that you might not know yet. The first one is the reflexive property, and that just means any segment is equal to itself. And the way I remember that one is when you look in the mirror, you see your reflection, and what do you see when you look in the mirror? Yeah, yourself, right? So the same thing is equal to itself. The reflexive property. The symmetric property is when you have two things equal to each other. So like AB is converting to CD, and you just switch the order. So then you write CD is equal to AB. And you think of symmetry. Symmetry is when you have the same thing on both sides, right? That's why the same thing is equal to itself. Transitive is kind of like the law of syllogism. So if we start out with AB is equal to CD, and CD is equal equal to EF. What do you guys think you can conclude? Yeah, AB is equal to EF. You can kind of skip out the middle. It's just like the law of syllogism. Okay, we've kind of talked about the definition of congruence, but now we're going to get it in some writing. So remember, all the definition of congruence is when you take off those segment bars and say that they're equal to each other. So you'd have segment AB is congruent to segment CD, and you can also say AB is equal to CD. It's more of a notation thing than it is anything else. And you can go the other way. You can have it AB equal to CD, and then say that their segments are congruent. Okay, let's draw a picture here for definition of a midpoint. What letters do they use? So if you were told M's the midpoint, what would you know about that picture? If M's the midpoint? Yeah, AM equals MB. So that's just definition of a midpoint. If they're giving you the midpoint, you can say those two parts are equal. Okay, and then our last one is the segment addition postulate. So I want all of you to write AC. So write AC equals. Now, what two things make up that whole segment? Yeah, so AB plus BC. That is your segment addition.
It's pretty simple.
Yeah. Okay, so those are essentially the only reasons you're ever going to use, and now we're going to write proofs with these reasons, okay? So today we kind of have training wheels on to start off our proofs. So the first one says E is the midpoint of DF. So what do I already know about this picture? If E is the midpoint. Oh.
D plus E.
Yeah, they're equal, right? So why don't you always mark your picture? That's your first step. Mark your picture, give yourself a visual, okay? And now we want to eventually prove that two of these equals the whole thing. Does that first even make sense to you? If two of these right here, two DEs, does that equal the whole thing?
Yeah.
It should, right? Because if this is half of the whole thing, wouldn't two of them added together be the entire length? Right? Okay. So our first statement says E is the midpoint of DF. What would your reason be? Given, right? If you have nothing else, guys, you can always write that first thing down. It's given. Okay, now it says DE is equal to EF. What would my reason for that be? Why can I say that?
With a midpoint.
Yeah, midpoint. So then we're going to throw the word definition in front. Definition of a midpoint. If you want to write just DEF, not write the whole word out, that's fine.
Oh, sick.
Okay, now this next one's goofy. So think, we're right here right now, folks. I have DE equal to EF. And then what happened? What changed in my equation from here to here?
You added
What did I add to both sides?
DE.
DE, right? So if I add something, what property is that? The addition. Right now we're kind of matching, right?
Mhm.
Yep. So now I'm going from DE plus DE to 2DE. How would I do that? Not dividing yet. How do I like consolidate that? What does that mean? Simplify. We're just adding like terms. We're just simplifying. And now we're told DE plus EF equals the whole thing. So go back to your picture. They're telling us DE plus EF is equal to the whole thing. You guys remember what property that is?
Segment addition. Postulate.
Segment addition. You guys can just write segment addition. You don't have to write the word postulate. Well, then obviously by process of elimination, we know this is transitive, but I want to show you why it's transitive, okay? So do you guys see how I have DE plus EF, and then I have a DE plus EF? Do you guys see that right there? So now I can set what both those two things are equal to each other. That's why I can use transitive. I'm matching, right? So now I can say 2DE is equal to DF by the transitive property. So like on a scale, just like do 1 to 3. 1 is like totally over my head, no idea. 2 is like kind of, sort of, and 3 is like, oh, that totally makes sense. 2, okay. All right. I'll take it. Okay. I'm gonna have you guys start the next one. There's little cheaters up here. So those are your 4 reasons. See if you can reason your way through this, and we'll come together. If you have no idea, that's okay. That is A-okay. Okay, so in this picture, do we agree that all those little segments in that picture are equal, right?
Yeah.
Okay. And our goal is to show that L is the midpoint of KM. Can anyone explain that to me, why that makes sense? Without writing a proof, just why would it make sense that L is in the middle of KM? Anyone know why? Why does it make sense for L to be the midpoint? What do these tick marks mean? Remember? They're congruent. What does that really mean, though? That they are the same, right? So if this is 5, what would this have to be? 5. So now does it make sense why L is in the middle? It's the same distance away? Okay. So, obviously, what was our first reason here? Given. Yep. Now, what happened from our first step to our second step? There's just a slight difference. What did we take away? We take away those segment bars. You guys remember what that's called? You have 3 options.
Congruence.
Definition of congruence. Yep. That's more of a notation thing than it is anything else. Now, why can we say that KL is equal to LM? Not the midpoint. What's KL equal to? LN. And what's LM equal to? So if they're equal to the same thing, what do I know about those 2 things? They're congruent. So that's actually the transitive property. And then lastly, we can say it's the midpoint by definition of midpoint.
Oh, I got one right.
Good job. That's good.
I got 4 for 4.
You're 4 for 4. Nice job, buddy. Okay, let's try one more. Do you guys want to try start it and see if you can fill in the blanks?
Yes.
Okay,
Yeah.
see if you can start it. And we'll come together. Really, you only have to find 3 things. I automatically already know what goes in my first box. That's my given. And then I know what I'm trying to prove always goes in my last box. So really, we just have 3 things that we need to fill in. Now let's see if we can fill in those 3 things. Okay, who remembers what segment addition is? If you don't know, look at your yellow sheet. Segment addition says what? It's the bottom one that we filled in.
You're adding up
Yeah. So what's my whole segment length on this picture? What's the whole thing?
PR.
PR is equal to what two things added together?
PQ and QR.
Bingo. So that's segment addition. That was good. That was really good. And now I need to figure out this reason here. So why can I say that 2PQ is equal to PQ plus QR? What are both of these two things equal to? They're both equal to the same thing, right? So now I know that they're equal. You guys know what property that is? Transitive. Okay. And then our last step, I go from 2 PQs to only 1. And then I lose this PQ altogether. So what happened to it? How do you get rid of it? Minus, right? So this has a retraction property.